Hello students. In this lecture, we are going to discuss velocity in mechanism by relative velocity method. So first of all, the principle of relative velocity method is velocity of any point, velocity of any point, velocity of any point on a link with respect to another point is always perpendicular to the line joining by these points on the configuration or space diagram. So let us see how this principle is work. So suppose this is a rigid link. The link is AB, rigid link, which is a rigid link, and it is free to move clockwise, and it is free to move clockwise or anti-clockwise. Okay, so in this diagram, in this link, the absolute velocity we know the absolute velocity of a point A in magnitude and also in direction also. So in this link we have to just find out the absolute velocity of point B. In this complete link we know the magnitude and direction of absolute velocity at point A, and also a only direction of absolute velocity at point B. So we have to calculate in this diagram the absolute magnitude of the absolute velocity at point B. So how this we reach to this calculation? First of all, our principle is the perpendicular to that link. Relative velocity is perpendicular to that link, so we can use this principle in this diagram to find out the absolute velocity in magnitude for point B. Okay, so let's start. First of all, we have to draw a line parallel to the line VA. Okay, so this is a parallel line we have drawn. I just draw, okay, from point O. From point O, I just draw a line parallel to VA, because the direction of absolute velocity we know. Okay, then draw perpendicular to the rigid link AB. So this is a perpendicular link okay. We know the dimension of this link AB. So after that, I just draw a parallel line to VB. This is a parallel line to VB, and the coincide of these 2 points, okay. this is a VA, this is a VAB perpendicular, and this is VB. So this is a complete velocity diagram of this particular point. After that, measure the distance VB, we get the absolute velocity of that point. Okay, so this is a very easy method and not a time consuming method. Just you can draw a perpendicular to link. So next diagram we also see how the method is work. So in this diagram we have to find out a velocity of point A, which is a slider, and the slider is the path of slider which is going to move, the slider is going to move is fixed. So we have to find out that slider velocity. In this particular slider crank mechanism, we know the angular velocity of OB, radius of OB, so and also a angle of OB. So in this particular diagram I just start a diagram from point O. This is a particular point O which is I have marked, and from this point I am going to draw a vector diagram, velocity diagram. Okay, so first of all draw perpendicular line this is a perpendicular line to OB from point O. I draw a perpendicular line from point O. Then the link AB is also a rigid link. It is a connecting rod and it is a rigid link. So relative velocity is obviously perpendicular to that link. So I just draw another this is a point O. This is point O, and another one is B. Another point is B. So I just draw a perpendicular from point B perpendicular to the AB line. So this is a perpendicular. I just draw this perpendicular to AB point. After that we know I just draw the perpendicular to AB line, mark A, just draw a perpendicular to the AB line, then AB link, then a slider come towards the slider. Slider is a slide along a fixed path, so it is a horizontal line path. So I just draw a line parallel to the horizontal line from point O, which is intersect at point A. Intersect at point A. So just this is a this is VB, V suffix B, this is VA, V suffix A, and this is VAB. V suffix AB. Okay. So by measuring the distance of OA, we came to know the velocity at point A. Okay, this is a very simple method. So then in the next problem, this is a 4-bar chain mechanism. In this, a link AD is fixed. A link is AD fixed. So in a problem, we have to find out the velocity, relative velocity of link CD. In this particular problem, we have to find out the link velocity of CD. So how we calculate this? In this particular problem, the dimensions of the links are as follows. The link AB is equal to 40 mm, link BC equal to 150 mm, link CD equal to 80 mm, and link AD, which is fixed, it is also a 150 mm. So first of all, draw this 4-bar chain mechanism as a space diagram by using some geometric instruments. First of all, draw a radius, a circle, crank radius of 40 mm radius. Draw an arc, and also after that measure a 60-degree angle AB from point A. Okay, this is along with point A from A point. I repeat the process. Draw first at point A, measure 40 mm radius. Take a some scale, suitable scale as you want to suitable. Then take a 40 mm distance. Draw an arc of 40 mm. Then after that measure an angle of 60 degree. Draw the line AB, which is our crank of this particular mechanism. Then draw line AD, which is fixed, equal to 150 mm. After that, from point D, draw an arc of 80 mm radius. Then after that, at point B, draw another arc of 150 mm radius and which is coincide with point C. Note down that point C. In this particular problem, the speed of crank is 120 rpm. So first of all, calculate the velocity of point B by using this speed of BA, which is already given, equal to 120 rpm. So angular velocity of link BA equal to 2 pi n upon 60, 2 pi multiplied by 120 divided by 60. So here we get the answer 12.56 radian per second. But we know the velocity, relative velocity. So VBA equal to VB equal to omega PA multiplied by AB. AB is a distance of crank and it is 40 mm. So in meter, 0.04 meter. So multiplied by 0.04 multiplied by 12.568 and we get the velocity of our crank VB, relative velocity of our crank, 0.503. Okay. So now, as our link AD is fixed, so take a point AD here. This is a AD point. From point A, we are going to draw a perpendicular line, from AB perpendicular line to AB. This line is perpendicular to AB from point AD. Okay, I just draw. Then small a comma small t. This is an AD point. A comma t. Why I take a comma t as a single point? Because link AD is a fixed link. So then moving forward towards, and we already calculate the distance velocity of VB equal to 0.503. So at some suitable scale we have to draw A to B by using some suitable scale. Then draw a perpendicular to line BC. Draw a perpendicular to line BC. This is a perpendicular line to BC from point B. I have to draw just, this is a perpendicular line to BC. Then moving forward towards the link CD, draw another perpendicular to CD from this point D. This is a perpendicular line and it is from point D. This is a perpendicular line and it is from point D and it intersect at point C with velocity BC. So this is a point C. This is VB, V suffix B. This is VC. This is VD. So we have to calculate the link relative velocity of link CD. So we have to measure the link VD. So we have to measure the vector line VD, that is our VD or vector line CD. To calculate the velocity of CD, we have to measure the vector of VD, and it is measure the vector of CD, and it is equal to VCD by measurement. VCD equal to vector CD equal to 0.385 meter per second. We know the dimension of CD. CD equal to 80 mm and in meter 0.08 meter. So angular velocity of link CD equal to omega CD. Omega CD equal to VCD upon the distance CD. We know the VCD equal to 0.385 by distance measurement of vector CD divided by 0.08. So we get the final answer of 4.8 radian per second, and this is our final answer, 4.8 radian per second. This is our final answer, 4.8 radian per second. 4.8 radian per second. Okay, so if any problem, then please feel free to call me. Okay, thank you.